Hello everyone and welcome back. Today I want to talk about Java basics and how it works basically. I have object-oriented programming exams coming soon and I just wanted to practice myself and repeat with the camera on. So let's start with how Java works. Basically, it has a Java source code. It is compiled by the Java compiler into bytecode, meaning the class files. This bytecode is platform independent and can run on any system that has Java Virtual Machine, JVM. We will talk about it. The Java Virtual Machine acts as a runtime engine that loads and executes the bytecode. In other words, it has a basic rule: write once, run everywhere, because the same compiled code can run on different platforms via the Java Virtual Machine, which is also responsible calling the main method in your program and managing executions. For example, let's have a new file called hello world.java, and Visual Studio Code gives us the basics, which is a public class hello world, and I will have the main function, public static void main, and it will just print hello world and welcome to Java programming. And as you can see, I will open my terminal. I will say Java compiler, hello world. And as you can see, it changed our Java program to class, which means bytecode. And when I say Java hello world, we have our output as we wanted. So this is basically how Java works. Java Virtual Machine is a virtual machine that runs Java bytecode. It provides important features like memory management and garbage collection. Memory management is used for heap for objects and also stack for method calls. And garbage collection is automatic deletion of objects that are no longer referenced. So the Java Virtual Machine is part of the Java runtime environment and acts as an intermediate part between Java programs and the underlying operating system like Windows OS, Linux OS, or Mac OS. So in basics, Java Virtual Machine enables Java's platform independence by abstracting the machine-specific details and executing bytecode on any device. When we come to class versus objects, a class in Java is like a blueprint or template. It defines a new data type by specifying that what attributes that data and what methods or functions it has. An object is an instance of a class, and it can have a concrete entity created based on the class template. For example, I have a class car here and an object called myCar, which represents one actual car with its own color and speed values. And it is an abstract class definition, while like an object is instance of that definition. Let's see in the Visual Studio Code. I will create a class called car, just like I showed in the example, and we will have another class called main.java. I can close the hello world, we don't need it at this point. And public class car. And let's have some attributes like string color, string model, integer year, and let's have a let's make it integer speed, and let's have a function called accelerate. Yes. Basically, when we call this function, it will increment the speed with the value we give, and we can say let's say accelerated to speed. Yes, that's okay. And we will have another function called break, which will decrement the speed with the value we give. We will go to the main now. Again, we will have a public class main, and it will basically do this. We will have a car object. We have a car class here, and we are creating an object called myCar, and we are setting its color, model, and speed, and we want to accelerate or brake in the car. We will use this function. Let's say Java car Java and main Java, and when I call main, we called our car class, we gave our myCar object, we gave it a color, a model, we accelerated to 50, and we slowed down back to 0. We didn't go to -10 because it doesn't make sense. That's why we have if speed is less than 0, speed is 0. But yeah, this is how objects and classes are working in Java, basically. Let's continue with our presentation. Like we said, class defines attributes and methods. Object holds the state and behavior, like the cars have models and years or speed, but the object is a special one, which is that Toyota in our case. And when we look at the state and behavior, things and object knows its data. So it knows its state. And things that are object can do is behaviors. So in Java, an object state is represented by instance variables, like or sometimes called fields or attributes. And its behavior is defined by the methods with functions, I mean. Each object of a class has its own copies of the instance variables, and so they can have unique state. But all objects of that class can perform the same behaviors or functions or methods, potentially yielding different results based on their state. For example, we have a car, which with the same models accelerate, but they may have been different states. One can be red, one can be blue, one can accelerate 50, one can accelerate 10. And yeah, that's the difference between state and behavior. And we have dot operator, which in Java, as we showed in the VSCode, dot operator is used to access an object's members. It's like its variables or methods or functions. And like we had car, myCar, a car class, an object myCar, which is a new car, and color was red, and we called accelerate method. So to access the color variable and accelerate method, we use dot operator. So essentially it lets you reach into objects or classes, state or behavior. To run a Java program, just like I showed in the VSCode, we were running hello world and the main. We are basically saying Java and we give it the class name, and then Java virtual machine looks for the class named whatever the class name you gave, for example hello world, and loads. Then it calls the classes main function, public static void main with arguments, and it starts execution inside the main. In short, Java class name launches the Java virtual machine that loads the bytecode of that class and invokes the main method, the empty program, and that's how it works. Let's show again in the VS Code. For example, here in the car, we have the class, but we don't have the main function. In main, we have the main class called main, and also we have the main function. And even though we compiled them together with car and main, if I say Java main, we get the output. But if I were to say Java car, main method not found in class car, please define the main method. So as you can see, if you want to make the Java run, you need the main method. If no main method, it's an error. So there's variable declarations. We can have some variable types. Like for example, here we have int for integer, which means like numbers, int score, int level, and string name. So score is integer is like self-explanatory. It's a mathematical number. Level is the same. You can just give it, you can initiate it empty, or you can give it a value. And also we have strings for texts, or not too large text, but for texts you can give it, like here, Alex, but under and first you need to declare them if you want to use them, and they have different types and very specific attribute depending on the data. Let's go to the primitive data types. We have, Java has 8 primitive data types. These are the basic types of numbers, characters, and Boolean values. For numbers, we have byte, short, int, and long. Integers of varying size, depends how long is your integer. We have float and double. For floating point numbers, for example, 2.5 is a float or double. We have char for single characters, and we have Boolean for true or false statements, and we have 5 common primitive types which can be asked, and you can just give any 5 of them. I would do like int, double, char, Boolean, float, or whatever you like. You should use correct type for the efficiency, of course. We have object reference variables. In Java, non-primitive types like objects are accessed via references. An object reference variable doesn't hold the object's value directly, but instead it holds the reference, like address or pointer. If you know some C or C++, you are familiar with addresses and pointers, which shows you the location in memory, like whatever the object, it shows you the location in the memory. That's points, like pointer. And for example, we have car, my car, which is an object, comes from the car class, and it is a reference variable that refers to a new car object created on the heap. So when you assign car another car as a my car, both reference variables point to the same object in the memory. It's important to understand that variables of object types don't contain the object itself, but only a pointer to it. So when you have another car, it just points to my car. So state versus behavior questions. I talked about this briefly, but let's say an object's behavior is defined by its methods, and state of an object is represented by its instance variables. So if the question gets like, what is the difference between objects' behavior? The answer is the method of its class and the code that can act on the object's data. What is different for them? And if we are getting asked like, what represents the state of an object, like that will be the values, its instance variables at any given moment. We also have parameters and arguments, which parameters are the variables defined in a method signature, whereas arguments are actual values you pass to that method when calling it. In other words, parameters are the placeholder used in method definition, and arguments are real data that you plug in those placeholders during a method call. For example, let's imagine we have a simple add function, which is an integer type. So we have integer at beginning, which is the function's or method's name is add, and it has 2 arguments, integer a and integer b, which returns integer a plus b. So this method allows you to get 2 arguments and returns whatever the sum of them, which is add. So when we have another variable called int sum, which calls the add method, giving 5 and 3, it will return 8. A and b are the parameters in this case, and 5 and 3 are the arguments. And in the VSCode, we also did something similar. In car class, we created the accelerate and brake methods, and we gave them increment and decrement parameters. And when we call in the main increment 50 or decrement 20 or 40, we are giving arguments to that method, and the parameters here, increment and decrement, will copy the arguments values. When we come to the pass by value, which is Java's argument passing, Java uses pass by value semantics for passing arguments to methods. This means Java always passes a copy of the value of each argument to the method, not the original variable itself. So if you remember, in C or C++, you can change some variables giving to the pointers and address to the function, depends on what it does, but you can have the 5 in one function and you can turn it to a 10 in another function. But Java, it doesn't work like that. For primitive types, it's a straightforward. The method gets a copy of the value. Like if you give it int 10, it will copy the 10 to the method. It will have the method will have the separate copy of the 10 you give it. And for object references, the reference itself is passed by the value, which means the method gets a copy of the reference pointing to the same object. This is an important difference to know. Encapsulation, which is a key object-oriented programming concept, is the object-oriented principle of hiding the internal details of an object and only exposing a controlled interface. So not everybody can access your code. In practice, this means like we declare instance variables like as private, so they can't be accessed from the outside of the class. And we provide public methods like getters and setters, or another. For example, we have public class car and we have two methods inside. They are also public because it comes from the public class. But in the beginning, if you say here private void, then in that case, it will give an error because we cannot access if it's private from our main. So I'm just gonna fix it back. If you ask like describe encapsulation of instance variables, a simple answer will be encapsulation means making your data members private and providing public methods to access them, thus hiding the internal state of the object from direct outside manipulation. In this example, we have private integer age and public integer get age, which returns the age. And we have public void set age, which gets the argument integer a and assigns age to the a, the argument you gave it. Basically, this means you cannot access my age because it's private, but you can use get age and set age functions to access my age variable and modify it. So in this video, we basically talked about Java Compilation Execution, Java Virtual Machine Basics, classes, objects, state and behavior, dot operator, variable types, variables and types, object references, parameters, arguments, pass by value, and encapsulation, which gets the basics, I guess. In the next video, I want to talk about inheritance, polymorphism, and object-oriented programming concepts. So thank you for watching and see you in the next one.